MSM3. We're talking about combining like terms and the distributive property. Just talked about the distributive property before, so we're going to sort of blend the two. What we have here is a really silly, easy example, right? 2A is a lot like having 2 apples. 3B is a lot like having 3 bananas. 3A, 3 more apples. The things we can combine are the things that are called like terms. So if they have the same variable, you can combine them and say, well, I have 5A plus 3B. When it comes to like terms, they not only have to have the same variable, but they also have to have the same exponent. So two things that would be like terms would be something like a squared plus 2a squared. They both have the same variable a and the exponent 2. However, if you had a plus 2a squared, those would be unlike terms because they have the same variable but not the same exponent. All right, another one. If you had something like 3xy plus a negative 2xy, those would be like terms because they both have an x and a y. So I can combine something with an x and a y. I cannot combine 3xy plus negative 2x because it doesn't also have the y. Another one that I could look at as an example, if you have 2y squared and 4y squared, those can be combined as like terms, but 2y squared and 4x squared cannot. They happen to have the same exponent, but not on the same variable. Last but not least, if I do a little bit of mixing and matching, if you have 2xy plus 7yx, that's actually the same thing, xy and yx, because with multiplication, we've got the commutative property, and we can switch the order. It still comes out to be worth the same. Something that you cannot mess around with would be like 2x squared y and 7xy squared. This one I'm not going to be able to combine. Notice they both have xy, but on the first one, the x is squared, and on the second one, y is squared. So the exponents have to be on the same variables. You cannot mix and match. You can combine like terms to simplify an expression by adding and subtracting their coefficients. So the coefficient is the number in front of the variables. Sometimes there's only one variable, sometimes there's more than one. So in front of the variable or variables. So what are the coefficients in each of the terms below? So 7x, the number in front of the variable, the coefficient is 7. 5xy, the number in front of the variables, is 5. X squared, anytime you don't have a number in front, that's because you only have one of it. And we don't write the one, we just write x squared, but that still is a coefficient of 1. And w, same idea. There is no number in front of the w, so the coefficient is 1. Simplify the following expressions by combining like terms. Sometimes I use highlighters for this because it helps me see the like terms. 2w plus 2w, I don't really have to worry about that one too much. But the next one, 4x take away x, I might even rewrite that as 4x take away 1x just to remember that the coefficient is a 1, which is 3x. 3y plus 7y, I can combine those, but I cannot combine them with the minus 6. So I might highlight the ones that can be combined and add them together to get 10y. And then you just write the minus 6 because it doesn't have a y, so it can't actually be subtracted from the 10. 7b4, not after, but b4, bad bingo joke, does not have any like terms, but the second and third terms are like. Positive 9b squared, positive 3b squared, those can be combined. Since I can't combine them with the 7b to the fourth, I simply write it, and then when I add the other two, I get plus 12b squared. 7x plus 9xy is already in lowest terms. I cannot simplify that anymore. First term has an x, second term has an xy. Now this one has a lot going on. If you choose not to use highlighter, another option is to use shapes. So 10xy minus 4xy plus 12xy. Notice that I'm boxing in the sign that's right in front of it. That way I make sure that I add or subtract them. So if I have 10xy's and I take away 4xy's, that puts me at 6xy, plus another 12xy is 18xy. That's why I don't want to forget about that minus right in front of the 4. Plus 6x, plus 5x, plus 3x, if I combine all of those, plus 14x. The next one, same idea. You could also use underlining. Some people will say 4x plus 7x plus 3x. And then the other terms, they might do a double underline as another strategy. So 4x, 7x, and 3x adds up to 14x, plus 8 plus 2 adds up to plus 10. Last but not least, you'll notice that some of the terms can be combined here in the middle, the plus 4y plus 8y, but not the others. So 9x plus 12y plus 3. If there's nothing to add it with, we simply copy it down and say, okay, well, this is still here. I just can't combine it with anything else. Sometimes you have to first use the distributive property and then combine like terms. So I might distribute this k and get 8k plus 3k plus k times k is k squared, and then go about combining my like terms. Now, one of the things that we do is the highest exponent gets listed first in our answer, and then we would combine the 8k with the 3k and put plus 11k. The best answer has the highest exponent listed first. 2x plus. Now I'm going to distribute that plus 4 to both of the terms inside the parentheses. I'm not just going to keep distributing it, but anything that's in the parentheses that the 4 is bumped up against. So 2x I copy, plus 4 times x is 4x, plus 4 times 3 is 12, take away x. So if I go back to my highlighting strategy, I might notice that 2x plus 4x minus x can all be combined. So 6x take away 1x would leave me with 5x plus 12. And some of you might wonder why it's not 12 plus 5x. 5x has the variable and 12 has no variable. Over here, the higher exponent went first because they both had a variable. Here, the higher exponent is going first. This one has an x to the first, and the plus 12 doesn't have any x's. Last in this set, I'm going to distribute that 2 and distribute that 10. You can't do it all at once because they are separated by addition. 6x plus 4y plus 10x plus 20y. And then I'm going to combine my like terms. So I might use the underlining, 6x plus 10x. Maybe I use a different color. I've got a plus 4y and a plus 20y. The 6x plus 10x is 16x, plus the 4y plus 20y, 24y. Alphabetical order is the next backup if you have different variables. So you'll notice I've got my x's in front of my y's, but really I would have taken 24y plus 16x as well. Last but not least is a perimeter question, and perimeter questions often involve simplifying. Write a simplified expression for the perimeter of the figure below. Perimeter is where we add up all the sides. So 5x plus x plus 2 plus 3x plus x plus 2. Now, since I'm not multiplying, there's no distributive property. This is just a series of things getting added. The parentheses aren't necessary, but since the side was x plus 2, I put them in the parentheses just in case it mattered. So I've got a 5x plus an x plus a 3x and plus another x. So just the x's, 5, 6, 7, 8, 9, 10, so 10x. And then plus 2 would be plus 4. The last thing that we have to do, because this is geometry and it needs units, I would put it in parentheses and then I would put my units. So is it centimeters, inches, feet? This one doesn't have any units, so we just put the word units. If it were area, we would put units squared. If it were volume, we would put units cubed. But as it is perimeter, we just put units.